Hi, welcome to the second tutorial under the section Calculus. Today's tutorial is titled The Factor and Remainder Theorem and Long Division. In terms of what you need to know to progress with this tutorial, you need to have a thorough grasp of the entire algebra section. We will begin by taking a look at the factor theorem. Factor theorem. If g of x is equals to ax plus b is a factor of f of x, then f of minus b over a is equals to 0. Let me use an example to illustrate. Let's say f of x is equals to x squared plus 3x minus 10. I know that x squared plus 3x minus 10 is equals to x plus 5 times x minus 2. Hence, x plus 5 and x minus 2 are factors. Let us test this using the factor theorem. F of minus 5 over 1 should equal 0 because x plus 5 is a factor. F of minus 5 over 1, or just f of minus 5, is equals to minus 5 squared plus 3 times minus 5 minus 10, which is equals to 25 minus 15 minus 10, which is equals to 0. And if x minus 2 is a factor, it should also work. F of 2 over 1, or just f of 2, is equals to 2 squared plus 3 times 2 minus 10, which is equals to 4 plus 6 minus 10, which is equals to 0. Hence, the factor theorem holds. Now let us take a look at the remainder theorem. If g of x is equals to ax plus b is divided into f of x, f of minus b over a will equal the remainder. Using the above example of f of x is equals to x squared plus 3x minus 10, if we divide g of x equals to 3x plus 4 into f of x, the remainder will be given by f of minus 4 over 3. Let us have a look at that. F of minus 4 over 3 is equals to minus 4 over 3 squared plus 3 times by minus 4 over 3 minus 10, which is equals to 16 over 9 minus 4 minus 10, which is 16 over 9 minus 14, which becomes 16 minus 126 all over 9, which is 110 over 9. We are now going to move into long division. By the end of this, you will understand why it is called long division. As we progress through this, please feel free to press rewind as often as you need to. Let us use the expression f of x is equals to x cubed minus 4x squared plus 8x minus 9, and into that we are going to divide x plus 3. Now, there are a few steps involved. Step 1 of long division. X into x cubed goes x squared amount of times, or rather x squared divided by x is x cubed. So step 1 was dividing the first term by the first term. Step 2. Multiply the answer we have by the entire quotient term. That means multiply x squared by x plus 3. X squared times x is going to give us x cubed. X squared times positive 3 is going to give us positive 3x squared. Step 3. Change the signs. Step 4. Add or subtract vertically. X cubed minus x cubed is 0. Minus 4x squared minus 3x squared is going to give us negative 7x squared. Step 5. Bring down the next term. That means that we take the positive 8x and bring that down. Then we start again at step 1. Negative 7x squared divided by x is going to give us negative 7x. Negative 7x multiplied by x is going to give us negative 7x squared. Negative 7x multiplied by positive 3 is going to give us negative 21x. Change the signs. Negative 7x squared plus 7x squared is equals to 0. Positive 8x plus 21x is going to give us 29x. Bring down the negative 9. 29x divided by x is going to give us positive 29. 29 multiplied by x is going to give us 29x. 29 multiplied by 3 is going to give us positive 87. Change the signs. 29x minus 29x is equals to 0. Minus 9 minus 87 is equals to minus 96. Essentially, what we have done, we have taken the expression f of x is equals to x cubed minus 4x squared plus 8x minus 9, and we have converted it to x plus 3 times by x squared minus 7x plus 29 minus 96. Or rather, f of x is equals to gx times qx plus the remainder. You can use the remainder theorem that we've done above to test if this is correct. If x plus 3 is being multiplied into f of x, f of negative 3 should equal the remainder. Let us test that. F of minus 3 is equals to minus 3 cubed minus 4 times minus 3 squared plus 8 times minus 3 minus 9, which is going to give us minus 27 minus 36 minus 24 minus 9, which gives us negative 96. Now I want you to have a go at the following examples. The first one I gave you to do read, if x minus 2 is a factor of g of x, which is equal to x cubed minus x squared minus 22x plus 40, find the values of x for which g of x is equal to 0. Now I've already got one of my factors. G of x equal to 0 means basically that that is equal to 0. I've got one factor. I need to find the other two factors. I'm going to do this using long division or synthetic division. It's going to be x minus 2 into x cubed minus x squared minus 22x plus 40. X into x cubed will go x squared times x is x cubed, x squared times negative 2 is negative 2x squared. Change the signs, add them, That's going to give me 0. Minus x squared plus 2x squared is going to give me x squared. Bring down the negative 22x. X squared divided by x is equal to positive x. X times x is x squared. X times negative 2 is negative 2x. Change the signs. X squared minus x squared is 0. Minus 22x plus 2x will give me minus 20x. Bring down the positive 40. Minus 20x divided by x will give me minus 20. Minus 20 times x is minus 20x. Minus 20 times minus 2 is positive 40. Change the signs, and that will give me 0. That means that g of x is equal to x minus 2 multiplied by x squared plus x minus 20. G of x is equal to x minus 2 multiplied by that. Now I'm looking for when this is equal to 0. I need to still factorize this into two factors. This will become x minus 2 multiplied by two factors of 20 that give us positive 1, x plus 5, x minus 4 is equal to 0. That means that x is equal to 2, or x is equal to negative 5, or x is equal to 4. And those are my three answers. The second one I gave you to do read: find the remainder if f of x, which is equal to x cubed minus 6x squared plus 8x minus 5 is divided by h of x, which is equal to 3x plus 4. Now our remainder theorem states that f of minus 4 over 3 is going to give us our remainder. In this case, that's going to be minus 4 over 3 cubed minus 6 minus 4 over 3, or negative 4 over 3 squared, plus 8 negative 4 over 3 minus 5. Plug that all into your calculator if you want to. Usually works out much faster. And that will give you an answer of negative 28.7, or negative 28.70 roughly. And that's your remainder when you divide f of x by h of x. Number 3 read: f of x is equal to negative 3x cubed plus 4x squared minus mx plus 6. And I said that it is divisible by g of x, which is equal to 2x plus 8. Then I said find m. The way we're going to do this, remember I'm saying that this is divisible by this over here. That means that f of minus 8 over 2, which is the same as f of minus 4, has to be equal to 0, because that is divisible into that. That means that f of minus 4 is equal to minus 3 times minus 4 cubed plus 4 times minus 4 minus m times minus 4 plus 6. That has to be equal to 0. That means that 192 plus 64, 192 plus 64, sorry, that's a squared, plus 4m plus 6 is equal to 0. That means that 4m is equal to negative 262. That means that m is equal to negative 65.5. The next 4 I gave you to do were all factorized fully. For number 4.1, the only information I gave was g of x is equal to x cubed plus 2x squared minus 20x plus 24. How do I find out what are the factors? I need to start by finding at least one factor. I'm going to use the test, trial and error method, and I'm going to say, well, let's start off with g of 1. G of 1 is going to equal 1 plus 2 minus 20 plus 24. That's not equal to 0, hence x minus 1 is not a factor. The next one I'm going to do is g of negative 1. Negative 1 substituted into all of these will give me negative 1 cubed is negative 1 plus 2 plus 20 plus 24, which again is not equal to 0, so x plus 1 rather is not a factor. The next one I'm going to do is g of 2. G of 2 will equal 2 cubed, which is 8, plus 2 times 4, which is also 8, minus 40 plus 24, which is equal to 8 plus 8 is 16, minus 40 is negative 24, plus 24 is equal to 0. That means that x minus 2 is a factor. I'm going to use this and synthetic division to find my other two factors. The way I'm going to do that is the way I've done synthetic division all the time. X cubed plus 2x squared minus 20x plus 24, and that's divided by x minus 2. X into x cubed goes x squared times x is x cubed. X squared times minus 2 is minus 2x squared. Change the signs. That will give me 4x squared, bring down the negative 20x. 4x squared divided by that will be plus 4x. 4x times x is 4x squared. 4x times negative 2 is negative 8x. Change the signs. Negative 20x plus 8 will give me negative 12x, bring down the positive 24. Negative 12x divided by x is equal to negative 12. Negative 12 multiplied by x is negative 12x. Negative 12 multiplied by negative 2 will give me positive 24. Change the signs. That should equal 0. Yes, it does. That means that g of x is equal to x minus 2 multiplied by x squared plus 4x minus 12. Alright, I can factorize this further. This will become x minus 2 multiplied by x plus 6 x minus 2 which will give me an answer of x minus 2 all squared multiplied by x plus 6. And these are all of the factors of g of x. The next one I gave you to do, number 4.2, read h of x is equal to x to the power 4 minus 7x cubed minus x squared plus 7x. This does look like a little bit of a nasty one, especially because we've got an x to the power 4, but remember we are factorizing. Is there a common factor? I can get a common factor of x multiplied by x cubed minus 7x squared minus x plus 7, and that's h of x. Now I can factorize this the same way I factorized it in the previous example 4.1, using first trial and error to get my factor. Once I got my one factor, which in number 4.2's case works out to be x minus 1, I can then factorize it into that to get an answer of x minus 1 multiplied by x plus 1 multiplied by x minus 7. These are my factors of h of x. Number 4.3 read f of x is equal to x cubed plus 4x squared minus 9. Again, using trial and error and my calculator, I find that f of negative 3 is equal to 0. That means that x plus 3 is a factor. X plus 3 is a factor. I'm going to divide it into x cubed plus 4x squared plus 0x minus 9. There is a reason I'm putting this in, and I'm going to show you now. X into x cubed goes x squared times x is x cubed, x squared times positive 3 is positive 3x squared. Change the signs. 4x squared minus 3x squared is going to give me x squared. Bring down the 0x. X squared divided by x is going to give me positive x. X times x is x squared. X times positive 3 is positive 3x. Change the signs. Aha! 0x minus 3x is going to give me minus 3x. See why we put that in? Minus 9 minus 3x divided by x is minus 3. Minus 3 times x is minus 3x. Minus 3 times positive 3 is minus 9. Change the signs. That will equal 0. That means that f of x, which is equal to x cubed plus 4x squared minus 9, is equal to, once it's factorized, x plus 3 multiplied by x squared plus x minus 3. It's equal to that over there times that. This here is the simplest form. We cannot simplify this any further, or rather we cannot factorize this any further, because x squared plus x minus 3 can't be factorized. If this were equal to 0, I would then say x is equal to negative 3, and I'd use my formula to work out my other two x values. However, I did not make it equal to 0. All I asked you to do was to factorize it. The next one we are going to be looking at number 4.4 read as follows. K of x is equal to x cubed plus 3x squared plus 3x plus 1. Again, trial and error method, I find that k of negative 1 is equal to 0. Therefore, x plus 1 is a factor. Dividing x plus 1 into this will yield an answer of k of x is equal to x plus 1 into x squared plus 2x plus 1. The way I got to this answer was by using synthetic or long division. This will equal x plus 1 multiplied by x plus 1 by x plus 1, which will give me an answer of x plus 1 cubed. And that brings us to the end of the section on the factor and remainder theorem. I must admit I was unsure as to where exactly in the Maths DVD tutorial I should slot this in, as it applies to both algebra and calculus, as you will see when we do the next section on calculus graph sketching. And that is the reason that I decided to slot it under the calculus section just before we do calculus graph sketching. Please note, however, that it, like all maths, it is applicable wherever you can apply it. Please have a go at the next few examples before moving on to the next tutorial.